Hi, so in today's lesson we're going to be looking at differentiation. Now this is just an introduction to differentiation, so we're just going to look at the basic scenario when we have y is some function of x. Now when we differentiate, what we're doing is looking at rate of change, so how one thing changes compared to another. Now in maths we can write that like this, dy by dx. That means how much y changes as x changes. So before we've looked at that, the change in y over the change of x, and we found the gradient. So actually when we differentiate, we find the gradient. Now when we have a straight line, it's easy. We just look at the change in y over the change in x, and that gives us the gradient. So that's nice and easy. But when we have a curve, it's different, because the gradient here is just not the same as the gradient here. And the gradient here is certainly not the same as the gradient here. So when we when we find the gradient of a curve, we have to find it at a particular point. So what we do is look at the tangent at a point, and we can say, looking at that line there, we can say the gradient is whatever it is, just as it skims the curve. Now we're not actually going to do the proof at present of how you differentiate. We're just going to look at how you differentiate. So what I want you to do is just spend a little time here just looking at these functions of x and what they look like after they've been differentiated, and just see if you can see any patterns. See if you can see anything which would help you notice what you might do when you differentiate. Okay, so when you've thought about it for a minute, you can pause, and then you can start the video again. So here we are. So hopefully you will have noticed that when you differentiate, you take the power. So here the power is 4. And when you differentiate your function, you take that power and you multiply your power of x by that power. You then take whatever your power was and you take 1 from it. So when you take 1 from 4, you get 3. So let's make sure that works for the next one. We have y equals x squared. So we've got the 2 here and we multiply by the 2. We take 1 from the 2, which will leave us 1 as the power. Now this one's slightly harder, but it's the same really. You take the power and you multiply by the power. Then you take 1 from the power, and that becomes your power of x. So 5 take away 1 gives you 4. But we just need to tidy this up a little bit. We've multiplied by 5, and so we just need to expand this bracket. So 5 times 2 gives you x. And then the last one, we got y equals x cubed. So we multiply by the 3, being the power. And we take 1 from the power, which leaves us with 2. Okay, so let's just look at it more formally. So this is what we say more formally. If y is a function of x, that means we've got here y is some number times x to a power, and when we differentiate, we take the power and we multiply by the power, and then we take the power and we take 1 from the power. So I'll say it again. You take the power and you multiply by the power, and then you take 1 from the power, gives us the new power. And of course, if a is 1, then we just have the power times x to n minus 1. And then if this, say, was 2 and the power had been 3, we'd have 2 times 3, which would give you 6. Now there's a couple of things before we move on to examples, to some examples I wanted you to think about. Now first of all, when we're differentiating a constant. Now when we have y equals a constant, we say that is y equals some number. So y equals 4 as we have here. Could be y equals 10, could be y equals 100, it doesn't matter. Now if we drew the line y equals 4, we would get a straight line through the point y equals 4. Now if I was to ask you what the gradient of this line is, hopefully you would know the gradient of this line is 0, because it's a flat line. So as x changes, y stays the same. Y just always equals 4. It doesn't matter what value of x you have. When x is 1, 2, 3, 4, y just stays as y equals 4. So we have a 0 gradient. So when we differentiate a constant, we get the answer 0. So dy by dx would equal 0. Now doing it more formally using the rule, if I had y equals 4, this is actually the same as y equals x to the 0, because anything to the power of 0 equals 1, and 4 times 1 would equal 4. So this and this are just the same. So what do? We take the power and we multiply by the power, and then we take 1 from the power, so 0 take away 1 will give me minus 1, but then anything multiplied by 0 would equal 0. So that's what we thought. We would get a gradient of 0. So when we differentiate a constant, we always get that dy by dx equals 0. Okay, you really need to remember this. It's important that you remember this. And then when we differentiate x to the power of 1, this is also something I want to go over, because some people find it hard. It's no different. It's the same way, but for some reason they find it slightly confusing. So if we have y equals x, hopefully you would know that if I drew y equals x, we'd get a straight line graph going through the origin with a gradient 1. So let's see what happens when we differentiate using the rule. Y equals x is absolutely the same as y equals x to the power of 1. And so what we're going to do, as before, we're going to take that 1, we're going to multiply by the 1 when we differentiate, and then we're going to take 1 away from the 1. 1 take away 1 gives us 0, and then anything to the power of 0 is just 1, and 1 times 1 will give us 1. So we get that the gradient equals 1. So what if we had y equals 2x? Now hopefully you know if we drew y equals 2x, what we would have is a straight line through the origin, and it would be steeper, and this time it would have a gradient equal to 2. So let's see what happens when we differentiate this. This is y equals 2x to 2x and x to the power of 1. So again, we take the power and we multiply by the power. And then we take the power and we take 1 from the power. 1 take away 1 is 0, and anything to the power of 0 is 0. So now we've got 1, sorry, anything to the power of 0 is 1, sorry. So now we've got 1 times 2 equals 2, and that's what we would expect. So when we have y equals a number times x, the gradient just comes out as what the number is. So if you had y equals 3x, the gradient, or dy by dx, would equal 3. If we have y equals 4x, dy by dx would equal 4. Okay, so here's some questions just to try. If you'd like to pause the screen and give them a go, that would be good. And then when you're ready, continue. Okay, so here's the answers. Now, hopefully this is straightforward if you've watched the rest of the video. So we take, using the rule, we take the power, oops, and we multiply by the power. And then we take 1 from the power. So 6 take away 1 will give us 5. Here we take the power and we multiply by the power, but this time when we multiply by the power, we'll also multiply by the 2. So we get 3 times 2, which will give us the 6. Now we take 1 from our power, which is 3 take away 1 will give us the 2. Now I know this looks harder, this one, but it's not really. You take the power, so the power is 3 over 2, the fraction, and then you multiply by that fraction. So you just multiply by 3 over 2. And then we take 1 from our power. So if our power is 3 over 2, when you take 1 from 3 over 2, which is 1.5, you get left with a half. Now y equals x, we've done that. So y equals x is the same as y equals x to the power of 1. So we take our power, we multiply by the power, we take 1 from the power, 1 take away 1 is 0, and anything power of 0 is 1. gives us the answer 1. Now this last one, you just have to differentiate term by term. So it's exactly the same. So you just focus on one term and then move on to the next one. So we take the power and we multiply by the power. We take away 1 from the power. So 2 take away 1 will give us 1. We don't need to write the little 1 in, but we can do. And then when we differentiate 2x, this is the same as 2x to the little 1. So we take the power, we multiply by the power. So 2 times 1 will give us 2. We take away 1 from the power. So 1 take 1 is 0. And anything to the power of 0 is 1. So that leaves us with 2. And then the last one, when we differentiate a constant, if you remember, when you differentiate a constant, you get 0, because the constant is just a flat line. Okay, I hope those questions helped, and I look forward to you listening to the next video. Okay, bye.